Welcome, everybody. So I see there's three of you out here, Shahil, Gurgis, and Shahil. Is that correct? Can you guys, and now, and Nicholas, can you guys hear me? Just give me a thumbs up. Um, welcome aboard, welcome to the Industrial Systems Engineering session. I am Professor Dasuki. I'm the department chair for the Industrial Systems Engineering. I am assuming that you gentlemen have been admitted to the Industrial Systems Engineering program. Is that correct? Check. Shahil, are you with us? Are you guys freshmen or are you guys transfer students? Please feel free to unmute and answer my any questions that I have, because obviously I'm here for you guys. So if there's any issues or clarifications you want about San Jose State, then the College of Engineering, or my department, Industrial Systems Engineering, please let me know. Are you guys able to unmute yourself and talk?
Yep.
Good. Just want to make sure, because they set this up for me, so I don't know how they set it up, whether you're able to answer questions only through chat or you're also able to answer questions ask questions through voice. So again, it's easier if you guys do it from voice, to be honest, because I'm managing a couple screens. That way, if it's voice and a small group like you guys, it won't be difficult. But after you ask the question, you may want to mute yourself, especially if you have some background noise. So first, I'm seeing that I'm getting a few more people admitted, so I have to admit them. So let me admit them before I get started. Give me a couple more minutes. While we wait for more people coming in the next couple of minutes, do you guys have any general questions for me? Again, I'm the department chair of San Jose Industrial Systems Engineering. I've been here since 1997, so I'm quite familiar with the university and obviously the department. I've been in the department, been responsible for a lot of things in my time in the department. Any specific questions? None? What is ISE in general? That is the number one question I have. I actually have a presentation for you guys. How many of you guys saw my presentation that's been posted?
I watched the welcome presentation for it.
With me? Doing it? Okay, I think most people haven't. So I'll take a few slides of it and really use it to explain to you what ISE is and what our department is. And I've updated some slides there. How would you like to do that as we proceed, group? To put a little formal structure to this session and also informal, combination of both. I see Josh Lee likes the Atlanta Falcons. Is that correct, Josh? That looks like a Atlanta Falcons symbol. So I'm mad. Students are still prospective students are still coming in. Eric is also just joined us. So how many of you guys, from a raise of hand, are been admitted as freshmen? Great. So I get 6, 5. So how many have been admitted as transfer? So it's about 50-50. So it's about 50-50 you. Okay, guys, let's get started. And please feel free to interrupt me throughout this presentation, okay? Can you guys see the presentation?
Yep.
Okay. So first of all, I'll just give you the college mission. Quite frankly, what we want to do is give you without reading it, is give you the best hands-on experience. I wish I had somebody here to keep on admitting people, because trying to present and admit at the same time is not the easiest thing to do. Okay, so I apologize if I interrupt myself a couple of seconds, because if I see some signs that people are being admitted, that want to get admitted, I have to admit them. I don't have somebody else on that task for me. There's another one that wants to be admitted. Okay, so San Jose State really prides itself on hands-on education, and I can definitely assure you that when you graduate from San Jose State, you'll be prepared to work in the workforce, number one. And it's not only me saying it; it's our employers say that. You know, the thing that they love about San Jose State graduates is they get the actual tools that we use in industry. If you go to Berkeley or Sense, you know, I'm not taking anything away from Berkeley, they're quite theoretical. They're not actually using the tools that the industry's using. They're basically teaching you a lot of just math. We do teach you math and the fundamentals, but we also teach you how to apply them a lot more so than some other universities out there that we compete with for industrial engineering. Actually, in California, there aren't many universities that offer industrial systems engineering. From the CSU, it's only us and the two Cal Polys and East Bay. And from the UC, you're only talking about one. That's Berkeley. So there isn't many industrial engineering programs in the California compared to the number of universities. But 5 is obviously more than enough in other states. So the vision is, what we want to do is we want to integrate your experience from a curriculum end, also trying to think out of the box a little bit more and maybe help you become an entrepreneur. Just give you some ideas of how you develop that. We have a lot of great speakers that come on campus, and especially in the College of Engineering, we have one every Thursday who discusses these kind of activities and from a career end. And we also wanted you to take advantage of, typically engineers only stay in the engineering type of campus, but especially from industrial engineering, you could definitely collaborate, and you're going to see some of our electives are not only engineering electives. For instance, you can have some business electives. You could also have some health electives where industrial engineers work at, also from a public policy aspect of doing the analytics to understand why certain diseases possibly may impact certain populations more than others. Industrial engineers can do that kind of work. It's because you're trained from a statistical and data modeling end, that you can look at data objectively and ask the right questions to derive the solution. I always say, and you're going to see me sometimes go on tangent, but the key to be a good industrial engineer, or actually a good engineer in general, is solve the right problem. If you don't solve the right problem, you can't get the right solution. And what ends up happening is you still have the same problem, but you have a lot less money now, right? Because you came up with a solution that didn't work. So it's always the key. I emphasize that over and over again. And I think we live in a world today that we don't always solve the right problems for various reasons. Now, in general, our College of Engineering, we have San Jose State is the largest engineering program in California. We graduate more students than any other engineering program in California. We have a full service. As you can see, we have almost every engineering program that exists, we have it at San Jose State. And we also have a very active master's program. We have approximately every year about 7,500 students, who are about 2/3 of them are undergraduates and 1/3 of them are graduate students. Please stop me if you have any questions throughout the presentation, okay? Can you guys hear me correctly, clearly? Good.
Yeah.
Okay. So how's our department specifically organized? Okay. It's myself as Amiyasu Suzuki, the department chair. Not only do we have the undergraduate industrial and systems engineering degree, we also have 3 master's programs: Masters of ISE, Masters of Engineering Management, and Masters of Human Factors. I do the career and mentoring advising. I don't know whether you've had a chance to meet with people from the Engineering Student Success Center. They'll do the advising from a semester to semester courses. And at San Jose State, every engineering student has to have, before they can register, have to have their engineering hold lifted. So this is an opportunity for you to meet with an advisor to make sure you're on path to graduate on time. And we also have now at San Jose State great software tools that keep you on track. You can always see by running a My Progress report how much longer you're going to need to graduate by telling you, okay, these are the classes that you've taken and these are the remaining classes you need to take. So our department, we approximately have 170 undergraduate students and 270 across our 3 master's programs. We have 9 full-time faculty, and me being the department chair. And our faculty's work experience is just like our alumni. We do work in manufacturing, healthcare, civil aviation, transportation, biometrics, process control. We get fundings from have had funding from various agencies in the past. And there's talk about maybe in sometime in the future that we'll have a joint PhD program with UC Merced. We don't have it. And a highlight of our College of Engineering is that we have more San Jose State engineering work at Cisco, Apple, and Adobe. Of course, industrial engineers also work in these 3 companies. And our student chapter is very good. It's always been very active. And if you do decide to come to San Jose State, highly encourage you that you still join the student chapter. So there was a question, what is ISE? Now we're going to get to that in general and then tie it to our curriculum. So it empowers students to better the world through innovative applications in many types of organizations. How do we always want to do things better, and it's always through a process improvement. In any organization, they're always going to want to do this, guys. They're going to want to minimize their cost, provide the product and service on time, and with customer satisfaction. Now, these 3 things can be opposite of each other, right? So how do you come up with the best strategy? Because if you're minimizing your cost, it may impact customer satisfaction to a degree. But how can you do it without you impacting customer satisfaction, right? So those strategies is always that 3 dimension: cost, time, and quality. And as an industrial engineer, you always focus on these 3 things. And obviously, depending on the type of industry you are, right? You would focus on one over the other. If you're for a nonprofit and health, you're definitely, the main driver is going to be, customer satisfaction from that end. Because it's profit. So what you're going to want to do is improve the quality of products and services. Make sure that you're working in a secure environment. Your workers have a quality of life improvement, provide excellent service to your customers, and you're on time, while you're also minimizing delays and cost. And we want to reduce any variability and waste, human errors, and risk of injury. Okay, let me give you an example here, what variability does to you, okay? In almost any process, organization has variability in the arrival of customers, right? The pattern of the customers coming in, right? And also the variability of providing that service, right? So let's compare an ER room compared to a scheduled appointment. In a scheduled appointment, we don't have as much variability in customer arrival because you have a scheduled time, right? But still, people don't always come in at 9 o'clock, right? If it's 9 o'clock, they may come in at what? 9:05, 9:03. And you also know why they're coming in. So the service variability isn't as much, but there might be a little bit. He may take a little bit, doctor might take a little bit longer with you a little bit. Just a little bit than scheduled. So there will be some waiting time. Compare that to the emergency room. Do they know why how the pattern of arrival for patients at an ER, guys? I don't think so. They can come for various reasons. And then you don't know when they're coming in, and you don't know why they're coming in. So that means you don't know the service that you need to provide them. So you have much more variability in the arrival pattern and the service provided. So how does that manifest itself? It manifests itself in extreme waits. So then you have to come up. So to reduce this, what did the medical profession sort of do now to sort of alleviate some of that pressure in the ER? Now, many medical facilities have this now. What do they do now, guys? Urgent care. They've set up urgent care offices to reduce, let me see what I got. 3 chats here. What is new idea? Try it. Oh, what is I? Yes, okay, got it. I just looked at the chat. Sorry, trying to parallel process here. So they have urgent care where people may go in there if they have a fever, coughs, maybe a broken bone, and just leave ER for complete major cases to help with the waiting times. So, you guys, we have students working in the shipping industry, United States Postal, FedEx, and UPS. We directly have people who do that. We have one of our top alumni actually set up his own company in the financial sector. We have students who work for Kaiser. We have students who work for United. And we have students who work for Lockheed. So they're everywhere. So what makes a good industrial engineering? Problem solving. As I said, make sure you identify the right problem to solve. This out of the box and being able to identify the root cause. Having your technical skills, you got to have good quantitative IE skills. We'll teach you that. And also be able to be a good team player and communicate well. And more job experience that you have, the better off you'll be. So any opportunity you can get to get an internship, I highly encourage it. So here's our curriculum and how I tie it to help you to some of the ideas that we've said that industrial engineers do. So what we're trying to gear, our senior design is a 2-semester project. It's a real world project with a company and an industry out there. And we're gearing our curriculum to make sure, because our senior design encompasses a lot of the curriculum. We have general engineering courses, because we all call them industrial engineering, with the engineering in the back. Our curriculum, though, is more dependent on math than science. That's the main difference between us and other engineering programs. The only one that's not as dependent as on science is also software engineering. So we're the two. So how are you going to improve an organization unless you understand how our organization operates? So we certainly have many courses that talk about how organizations operate and how the different activities that are going to be part of the organization. And we have some of these courses are required and some are electives. The first 4 are required and the last one is an elective. Then we need to have a thorough understanding of management. As we said, problem solving, communication. So what's management's role in an organization? What's an effective management strategy? Next is we want to improve a process. We don't want to implement the recommended thing right away. We want to test it through different models and understand its behavior. Against various scenarios. What happens if we add another machine? What happens if we make a process faster? What happens if we add a buffer here? What happens if we eliminate these 2 steps? So we want to test all these things. And I call these types of courses math modeling. Then we've got, obviously, a part of any system is humans. So these courses address humans' role for an aspect and how do we make sure the environment's safe for them. And that's what these courses address. And then, as I said, quality is another domain that industrial engineers have to be cognizant of, as it's a very important parameter in customer satisfaction. So we have courses in also quality here. To how do you improve your quality and how do you reduce process variability? Any questions from the audience? None? Raise your hand if you at least now have a little better understanding of what industrial engineer is doing. And I'm going to give you even a better understanding, okay? Continue. And we did an alumni survey lately, and we asked our alumni, where do they work? As the screen shows, they're everywhere. We're everywhere. Google, Tesla, UPS, name it. You see logos from everywhere. So on. Kaiser, as we said, LinkedIn, Berkeley Labs. So on. I got some more slides. Converse, anybody likes shoes? These are not made up logos. These were our alumni. All right. One's actually, this one needs to be updated. When he gave it, he was the city manager of Chico. Now he's the city manager of San Dimas in Southern California. eBay, just to pin out. Finstar, FAA. Every time I look at this, and our students are compatible with any other engineering majors. Now, this was taken a little bit long a time ago. The average salary is going to probably be 65 to 70. It could be higher, up to 80. Our masters students get 100,000 starting. So some of the hands-on. If we had an open house right now, you guys would be in this lab. You would be in this lab right now. And we've converted this lab. It's a state-of-the-art lab. It first was converted to be a wireless lab, as you can see. Took away a lot of the wires in it. However, we've even improved it further. We were fortunate to get 2 robot donations from Omron. One is the pick and place robot. This is a state-of-the-art robot to do pick and place. As you can see, there's the gripper right here. It picks up parts from pallets. Then it goes around the conveyor. And then we have a mobile robot that moves around the lab. And then we have a storage rack right here. And as you can see, we have the Omron logo because they've donated that. And we also hold the lab classroom in there. So you have computers in front and the board where you learn from the instructor and some storage area over there. We're very excited about this lab. We've had many visitors from industry who are quite awed by the sophistication of this lab. And if you do take it, decide to come here, you will have a course utilizing this lab. And we also have a human factors lab, which is used for observing experiments. And the person who developed this lab is Dr. Dan Nathan Roberts. And he does a lot of work on home care, from nursing coming to the homes of individuals. So what you have is an observation room that they can look in and observe, the care that's being provided. And from a training end, we've actually had some nurses come here and do some training in this lab. As you can see, this person's observing the activities that are going on in that room. And we also have what we call the lean and data analytics labs. We have some very powerful servers that's connected to very state-of-the-art software to run data analytics. Let me pause here for a moment and give you guys an opportunity to ask me a question. Somebody give me a question.
Can you tell a little bit about the manufacturing side of things in relation to like industrial engineering?
Sure. So the difference between us and ME, let's go back to that picture of that lab, okay? So the difference between us and an ME would design the robot. If your love is how to make this robot, design it and how it looks and all, that's ME. An industrial engineer, remember, we're interested in throughput. We want to make sure we can produce X amount of parts per day without waste. So what we're going to do is demonstrate how do you operate this whole manufacturing cell, work in sync, and it works efficiently. So what's the pace you should set the conveyor? So the workstations are, you minimize the wait time in any one of the workstations. We also have to have some 3D printers. So once you may manufacture a part here, how do we schedule the robot here to pick it up and then put it on the conveyor so they can place it on the rack? So what we want you to walk away from it, from this manufacturing end, is the operation of this manufacturing cell as a system. How can we integrate it to make sure that we're not operating as a standalone units, like islands? That sometimes occurs. Did that help address that question?
Yeah, for the most part. I got it.
Any other questions?
I had a quick question. Do industrial engineers learn things like machine learning?
Yes, you do.
Or-
No, data. Let's go back to. Okay, where's 194? You have this is a required course. This is 1 unit workshop. And here you learn R and Python. Just learn how to use them. But then we've just got a new elective, which I would highly recommend if you decide to come here to take it. Then this course right here then ties it to how do you do machine learning. And the person who does it is really big on using prediction from a manufacturing end with machines, is when should we try to predict when we should do preventive maintenance. Remember, there's two types of downtime. One is scheduled maintenance, and the other one is unscheduled maintenance. Just like with your car, you always want to do as many scheduled compared to unscheduled. Unscheduled is really what hurts you from a business end. So when can you predict? When should I take it in for some regular routine maintenance? Or also doing maybe data prediction to predict customer demand. You don't want to have too much inventory, do you? The two things I'm telling you right now is really the very difficult things. Or do some predictive demand to see what factors maybe influence cancer or kidney disease. Well, I had a research project with the VA some time ago, and we had a whole bunch of factors, and we were using machine learning, as you were saying here, asking about, and we were trying to predict what factors influence PTSD. And there was we were given about 20 to 25 different factors, and we reduced them down to 5 through machine learning and statistics. Any other questions? Bring them on. This is your hour, guys. Okay, so what we have all done is we're one of the smaller departments from the undergraduate, but not overall, because we have the third largest graduate program. But from the undergraduate, we're one of the smaller ones. but we have some of the most loyal students. Even though we graduate less than some of the very large departments like EE, mechanical, and computer engineering, we had the largest number of alumni show up to our events. They feel very connected to the department because the students in our programs really support each other. They get support from faculty. And then another event is we've used our alumni here. Here's a couple of my alumni, and these are our current students. And we had an alumni mentoring event that goes on. So that's what we expect of our alumni, come back and give back. And as you can see, we had a mentorship dinner back here. And she was the president of the alumni club at the time. And now we're very successful at Cisco. So what industrial engineers do, here's some of the activities we talked about right now. Where do they work? Everywhere. And here's some job titles. You notice you don't only apply for an industrial engineer job title. I guarantee you, every business needs the work what industrial engineers do. What they may not have, though, is they may not have an industrial engineer do that work because they may not know what an industrial engineer does. But more and more now, almost every business understands the need for industrial engineering. Any questions? How many of you guys are seriously considering coming to San Jose State in the industrial engineering program in the fall semester? Raise your hand.
Sorry, I couldn't quite hear you. Could you?
I don't know why. Serious. Let me see this. I got not everybody, so only a few of you. So the rest of you, were you? What attracts you to coming to San Jose? Come today's open house. If we're not one of your choices right now, I'm okay. It's just trying to understand, what my audience is, what they want out of this meeting here today. Yeah, you obviously wanted something, guys. It's 75 degrees outside, but you're inside now. How many of you will be coming in from a community college, local one, or someone from Southern California? Anybody in the audience from Southern California? Samir, welcome. Which part of Southern California? You guys are a such shy bunch. Again, to be successful, I had a student when I was a student. Remember, I used to be a student, of course. That's what a lot of students don't realize. Their professors were students at one time. Now, whether you decide to come to San Jose State or not, this is something I would always remember. There's a big difference between cheating and working with others in collaborations. When I was a junior, I was walking I had a very good female friend, and she finally started talking to me. We started working together, and she goes, "I didn't realize for my first 2 years here that you can work with others." And she was really floundering, barely surviving in school, making it, but really struggling in her classes. Once she started to work with me and my other friend, her grades just shot up. Everything, she became a much better student. Her confidence, you could see her confidence grow by teaming up with other people. Universities are a big place. Highly recommend for you to find other students who have the same expectations from school as what your expectations are. Very important. Now, unfortunately, the transfers don't have that issue because you're going to come in from day one and start taking ISE classes. Freshman is where you're going to be taking your GE, general GE, and math classes. So that's a little bit harder to do your networking. But the more networking you can do, that's why it's very important for you to join the student club, because the student club will help you through this. That we have mentors, and there's a very supportive group of students. Do you have any other questions?
Oh, what's your favorite part about industrial and systems engineering?
It's the way. I think it's a way of life. You know, when I drive, I know it drives my wife nuts, but I'm always thinking. I never needed MapQuest, to be honest, because I can visualize roads. I just can't see. I can visualize. Okay, this will be a shoulder cut. Always trying to take the best way. That's the problem. Technology is almost making me taking away a lot of the fun things I'm doing. So, what's the shortest way to get to a place? Let's say you have a list of. I'm always trying to do things better and faster, and thinking about ways. Let's say you have a list of 5 activities that you have to do, and they're all due by the end of the day. Which one should you do the first? Let me ask you guys that. There's no rule. It's okay.
The hardest one? Yeah.
That's what most people will say.
Yeah.
That is what most people will say. But that's what gets us in trouble. Your motive is right. Right? That's the right motive. But you'll find out, and that's proving mathematically, that if you do the shortest ones first, you'll have less people waiting on you. And that's the goal. The average waiting time is going to be much shorter if you do the one that is fastest first. So I always do the fastest first. Give you something that you guys all industrial engineering you can apply to your everyday life. I already told you about what's the best route to take, right? That you're always thinking about. How about when you go shopping? From an inventory, corporations shopping is just like inventory, right? So we all know that if you buy a case of soda per unit, it's going to be cheaper than if you just buy one can, right? Everybody agree? Yep, per unit. But why don't we always buy a case? Then let me throw that around. Why don't we always buy a case?
Maybe you want multiple cans. Maybe you have a party.
You want a variety. You want a bigger variety. That's a very good answer. But also, if you buy a case, even though per unit is cheaper, it costs you a lot more. And let's say you don't drink much soda. You might drink one once every 2 weeks. So you keep your money tied up and the demand isn't there. So, and also, you're tying up a lot of space compared to the one can. If you're a student, you may laugh, but you may not have that in your room, that kind of space in your room. So you have to factor in your demand and try to find what's the optimum point. Because organizations don't have money where they can just keep all their money tied up, just like you don't have all that to keep your money tied up. That's an industrial engineering kind of problem where you try to figure out what is the right order quantity. As you can see, I've already given you several examples in your day that you can use industrial engineering. I love solving problems and coming up with better strategies and to improve them. Because you know why? I've always hated waiting. I've always hated waiting. And I remember as a young person, I would go to the grocery store. I could never figure out why people don't do their own problem solving. I would see grown adults go to the line that's longest and not try to understand the different lines and go to the one that's shortest. I guess people are just comfortable doing what everybody else does. So they just follow. I noticed that at a very young age. So I said, wait, let me see. There's a couple lines over there. What's the reason why no one's there? Well, let me go check it out. I always try to come up. Again, maybe it's because maybe I'm again my dislike of waiting. This is why I really chose this profession. Unnecessary waiting. Of course, there are times and situations you have to wait for, but when it's unnecessary, that's frustrating. Any other questions from the audience out here?
Is for industrial engineering, is the freshman workload like a lot, like compared to like CS or CE?
It's the same. It'll be the
Okay.
same. You have to take a programming class like they do. We have one. We have the math classes. We have the physics classes. So it's all the same. Be honest with you, the first 2 years of engineering, it's almost 90% identical. So you can always transfer in or transfer out to another department. What's important, the big takeaway, is if you want to do that, make sure your GPA is high. Don't get so hung up. And if you're a freshman, what's my engineering major? The key is making sure you have good grades. If you have good grades, you can change your mind later. If you don't, then it makes it really hard. Any other further questions from the audience?
Will the classes be like online or hybrid?
Very good question. We were asked, we were looking at the fall semester. I was surprised it took, to be honest with you guys, 45 minutes for you guys to ask that question. I was expecting that would be the first thing on your mind. Okay, this is the initiative that we're at today. We are looking at the fall semester as a transition semester. So what does that mean? We want to be about 50-50. And the way we've defined it is 50, if your class size is 50 or above, then you'll be online. Less than 50, you're going to have in-person or hybrid. And we're going to repopulate the dorms a lot more this year. I don't know. Anybody here thinking about living in the dorms? Few of you guys. Yeah, so the plan is definitely to try to get some more students in the dorms in the fall semester. So what we're looking at is trying to get back to 50-50 in the fall. Hopefully for the spring, go back to as best as possible to what it was before. But obviously, just like in any kind of major event, there are going to be some changes that will remain online because we just figured out that it just worked better. So things will never go back 100% the same. And the reason they may not to is because we've had lessons learned from a process improvement. That these processes are better if we can do them online. Okay? But great question. I was very pleased that someone answered it because I would have felt, that, I would think that would be a number one question coming from you or yourselves and your families. Any other questions? Anything on your mind?
Would there be any reason like we do any type of projects or stuff in the machine shops in like I guess normal industrial and systems engineering? We don't do as much manufacturing as technology. Let's make perfectly clear. This is industrial engineering, not industrial technology. So I hope you guys are not confusing the two because I know sometimes I have an industrial technology person in here. Then you guys do a lot more machining. Yes, in the aspect of machining, yes, you will build something in that lab of ours with ISC 115. You definitely will be building things from the 3D printers and CNC machines. So the answer is yes. What kind of CNC machines do you guys have?
Let me see if it's in the picture. We have a lathe, but I want to see if we have a picture of it. I don't recall. Let me see if I can see a picture of it. You can see part of it over there. See that right over there?
Oh,
Right there. Let me see if the other one, the older one picture has it. Yeah, here it is. See that?
Oh yeah, I see it.
Do you see right there? It's right there.
To the back, yeah.
It's still there. We got another one that was given it to us that we're upgrading to make it coordinated. And actually now I think I have 3 of them between the lathes and the mills. So yes, you will definitely get an opportunity to do that.
Okay.
Are you industrial engineering major? Because it looks like this is your passion, or are you industrial technology?
So when I was looking through like applying for majors, I was really interested in like manufacturing engineering, specifically at the Cal Polys.
Yeah,
But
they're
around here,
much more. Yeah,
I was interested also in the industrial and the systems over here. But you're saying industrial and what was it, technology?
So there's let me make this so it's clear. Now, where you're talking about Cal Poly, they actually have 2 different degrees. They have the
Yeah,
industrial
yeah.
engineering degree and they have the manufacturing engineering degree, right?
Exactly, yeah.
And they're both under the industrial department. Now, if you're interested in really manufacturing without having to take as many engineering classes, what I mean by the pre-engineering classes is calculus, physics, and chemistry. We have a department called the industrial technology. They have a lot of similar courses as us, but they're not engineering based.
Okay.
So if you had asked, somebody had asked the question earlier, is industrial engineering as hard the first semester as I think you guys said EE or mechanical or computer science, something like that, computer engineering? And I said yes. Now industrial technology would not be the same. They don't have the same kind of math and physics as our as that.
Okay, yeah, I'll make sure to check that out then. Okay.
Right. So that's, yeah, you'll definitely get a lot more manufacturing from that department than our department. But I want to make clear to you that you will not graduate with an engineering degree. It's a technology degree. Now, I don't know if that's a big deal to you or not. That's up to you to decide. Any other questions? Let's see if I have any other slides. So what kind of questions? Disneyland. It's all about reducing the waiting time. Disneyland and Disney World is run by industrial engineers. I'll tell you service companies that are really run by a lot of industrial engineers. Disneyland, Disney World. A whole IE groups. I've had students do internships there. Has anybody been to Disneyland and done the fast pass? Fast pass is all industrial engineering. But they also found out everybody thinks it's only to benefit the customers, but it also benefits Disney. Why does it benefit Disney?
Well, you have to pay for the fast pass and they get to shuffle more people through the rides.
Well, you're right about, you're 50 right. You don't have to pay for the fast pass. It's part of the thing that you get in.
Okay, I don't remember that.
But they don't pay. But remember, just like in any organization, they don't want people waiting in long lines forever because that means you're not spending any money, right? If you're waiting, is there any movement of cash flow? No. If someone says, okay, come back in an hour, what's most likely you're going to do? Maybe go shopping, get something to eat. And they saw their revenues go way up because of the fast pass. Smart move. Customers, I mean, wouldn't you say that this is a win-win solution? Customers are happier and you make more money. Who can argue with that, right? Exactly the point. They're huge. Have anybody ever been to Disney World? I have. I took my family there. Once you even flying into Orlando, Disney World has a bus that picks you up and brings you to their hotels, which is like they have over 25 hotels there in this community, and it's all run by industrial engineering concepts. Okay, facilities layout. How should the plant be laid out for efficient movement? Where should the departments and the stations go to maximize output and minimize cost? Again, I'm giving you what I want you to walk out of today is definitely a much better understanding of industrial engineering. Should a conveyor system be used? If so, what kind? How fast should the conveyor move? Where should we expect items? How many items can fail before we stop the line? All types of questions we like to answer. How should we arrange the bins? Where should the soldering iron go? How about worker safety? Should the chair have arms or not? Footrest, back, for ergonomics. How should letters and packages be sorted, processed, delivered? What routes should be the best for the planes and the trucks? We have industrial engineering military. Remember, you never want your troops without having equipment at the right time in that. So how do you provide the military bases with the right resources? Where to fly, how often, what's the ticket prices? Ensure that those with reservations get a seat, design the flight, maximize the probability that the flight is full. So how many of you guys have ever been on a flight that's been overbooked? Come on, you guys must have, right?
I have.
So why do they do that? Why do they do that? It's because they've done math models to say that X percentage of people don't come, will not come to that flight. So they might overbook it by 20%, because that's that 20%. They're willing to take that risk, because I'm sure they've done numbers long, they've done mathematical studies and found out, because if they overbook, what do they have to do? They give you a big perk to go on the next flight, right? They might give you $1,000 of vouchers, right? That's still cheaper in the long term, because the probability of that happening is much less than people not showing up. So it makes good business strategy from their end. So as I said, we want to increase profits and customer satisfaction, both at the same time. What type of switches do you use? Toggle, pressure, dimmer? What light flashing frequencies? What's the best design for that cockpit from a human experience? What's the best colors? All about from the human side, these questions are. Ergonomics too. Best placement. And colors and so on. Medicine. What kind of patterns can we identify to help us predict whether a person will have Alzheimer's disease or not? I was just reading a paper, someone was using machine learning to determine what kind of patterns help us predict whether someone would have Alzheimer's disease or not from the brain. And so forth. So I think hopefully you guys have a much better understanding now of industrial engineering. Let me see if there were any chat questions that you guys had. Well, I had a question about industrial technology concentration on computer network system. If I were you, I would attend the industrial technology session from that. That's a different department. And I can tell you what time their session is. I don't know if their session is at 12:30 or 1:30. But if you hold on for a second, I can tell you. The 1:30 sessions. Oh, you're in luck. There's a 1:30 session with industrial technology. So I recommend you go to that one. So it's not a 12:30 session. They're over the 12:30, 1:30 sessions. Are any of you guys planning to attend other sessions besides mine? Well, with that, if you don't have any further questions, I hope you guys enjoyed today's session. You learned a little bit more about industrial engineering and specifically industrial engineering in San Jose State. And my name is Yasser Dasuki. And please send me an email if you have any questions later on that comes up that it wasn't answered today. I'd be glad to help try to clarify it for you. And I hope to see you guys next fall. Okay? Guys, enjoy the rest of your afternoon if you don't have any more questions. All right, guys. We'll see you. Great day.